Welcome to today's class. Today we will discuss characteristics of sound. So last classes we had discussed about free vibration, then we had discussed damped vibration, forced vibration and resonance, and other examples of resonance we had already discussed. Today we will discuss characteristics of sound. So here when we are considering two sound wave it is considered, and how to distinguish these two sound waves. So these two sound waves can be distinguished from each other by three fundamental characteristics. There must be some characteristics by which these sound waves can be distinguished. So these two sound waves can be distinguished by three fundamental quantities. One will be your loudness, another one is pitch, and third one is quality. And we will discuss one by one. So loudness is the characteristics of sound by which a loud sound can be distinguished from a faint one. The loud sound can be distinguished from a faint sound, both having the same pitch and quality. Why it is taken as both having the same pitch and quality? Because when we are comparing loudness, out of three factors, one we are comparing, so other two factors should be constant. Then only comparison can be effective for us. So that is why here it distinguishes a loud sound and a faint sound. Actually, this loudness is a sensation. Loudness is a sensation. Okay, cannot be measured. It cannot be measured. So it is a subjective property. So it is a subjective property. So what is subjective property? Subjective property is that property which cannot be measured. Objective property is that property which can be measured. So if we are discussing this is subjective property, what will be its objective property? So for loudness, intensity is the intensity of sound. Intensity of the sound is the objective property. Objective property. Because this intensity of a sound is nothing but the energy that we are providing. So as energy can be measured, so intensity also can be measured. That we will see this one here. So what is the definition of intensity of sound? So intensity, as it is I have told you, it is that energy. So let us see the intensity of a sound wave at a point of the medium is the amount of sound energy passing per second normally through an unit area at that point. So here what will be the unit? Unit will be watt per meter square. So it will be watt per meter square here. So here this particular thing is important. It is the amount of energy. This intensity of sound, it is nothing but your amount of energy. So more is the intensity, more is the energy, more is the intensity, and vice versa. So less will be the energy, less will be the intensity. So what is that normal ordinary sound wave intensity of ordinary sound? It is 10 to the power minus 6 watt per meter square. And what is that minimum intensity? Minimum, that is 10 to the power minus 12 watt per meter square. So here intensity, it is that energy. So intensity, it is the measurable quantity. So when we are discussing this loudness of sound, here when now we have discussed this intensity, so it shows that when we are providing energy to the body, that energy will lead us to loudness. Now let us take a tuning fork, and this tuning fork slightly you strike it just slightly you strike. Okay, slightly you strike. So when you are striking it slightly, then whatever the sound comes, that one will be faint sound or the feeble sound. Yes, though when we are this one, it is strike hard, then what happens? We are getting loud sound. We are getting loud sound. Here, in case of slightly we are striking, means less energy we are giving, less energy. Here, striking hard, providing more energy. Yes, understood that one? So, what we can say, loudness of sound depends upon this amplitude of the wave. So, here, loudness of sound depends on amplitude. Amplitude of the wave produced. Okay, so now let us see for us what we can say. Here, let me take graph. So this case I have taken time, and this case I have taken displacement. Okay, so here let me take the first graph. The first graph let me take. Let it be graph A. This is A. So now let me go for the second one. Do you think amplitude of graph A and graph B are same? No. So obviously let it be A, let it be A1. A1 is greater than A. So which one it is that louder sound it is produced? Obviously graph B, this one produces louder sound, whereas this one will produce faint sound. This one will be a faint sound. Again let me tell you, loudness is the subjective property, cannot be measured. It is a sensation only. And intensity, it is the objective property which can be measured. More is the energy carried, more is the loudness. Means here, in case of B, energy carried will be more. That is why it will be louder. And in case of A, energy carried will be less. That is why it will be a faint sound. So now let us discuss factors affecting loudness. So first factor and the interesting factor is that loudness depends on amplitude. Loudness depends on amplitude. So when we are discussing loudness, it is the not measurable quantity. So what is the measurable quantity? Intensity is the measurable quantity. So here this intensity of sound directly proportional to the amplitude square. Okay, so remember this one, this is most important thing, and basing on this question comes. So here what we can write, I1 by I2 is equal to A1 square by A2 square. So question comes, if ratio of intensity of sound is 4:9. Find the ratio of its amplitude. Okay, so what is the ratio of their intensity of sound is 4:9. So I1 by I2 is equal to 4:9 is equal to A1 square by A2 square is equal to 2 by 3 whole square? Yes or no? Getting? So what it can be? So here A1 is to A2 is equal to 2 is to 3. Are you getting? Understand this one? This question, it is given always in the form of this, means you can define this square root. So don't get confused. Let me change this question. I hope you understand this one. Take the screenshot. Now I will change the question. So here question will be the ratio of amplitude of sound wave is 4:9. Find the ratio of its intensity. Okay, so as it is 4:9 it is given, children they always get confused for it, so they can, it is given 4:9 means can be half the square root, so that is why they write it 2:3. So here what it can be, intensity it is given I1 by I2 equal to A1 square by A2 square. So what is A1? 4 square by 9 square. So what it can be? 16 is to 81. So I1 is to I2 equal to 16 is to 81. All these are, this is the important question for us. Clear? I hope you understand this one. Now, next we will go for it. Next will be depends upon the surface area. Here depends upon surface area. Depends on the surface area. Depends upon surface area. Here loudness directly proportional to the vibrating area. So here more is the vibrating area. Vibrating area, more is the loudness. More is the loudness of sound. Here this one to the surface area, this is directly proportional. More is the vibrating area, more will be the loudness. The best example you can take, the bell you are keeping at home with the puja room, that one is the small surface area. Let it be the small surface area, we are taking this one at home. But in case of temples, we are having the big bells. Okay, so in case of big bell, this one will be round one, no? So all these are the surface area, means vibrating area is more. That is why louder sound will be produced here. Otherwise, this another example also it can be taken. Let us take two drums. This one will be the small drum. Here this is the vibrating area. Let us take the another drum. This one having another this bigger surface area. So this is the surface area, and here this is the surface area. In which case that louder sound will be produced. Obviously this one will be louder sound will be produced. Here this one will be a faint sound will be produced, because this is the surface area will be less. Usually question comes, why this church bell has this, it is the bigger in size. So here bigger, one thing remember, bigger will be the size, more will be the vibrating area or the surface area to vibrate, more louder will be the the sound produced. Okay, next one what we will discuss, the loudness of the sound depends upon density. So here depends on density. Here depends upon density. Okay, so here you can write loudness, more is the density, more is the density of the medium, density of the medium, more is the density of the medium, more is the loudness. Yes, so density more, loudness will produce more. Next one will be, it can be depends upon the presence of these resonant bodies. So here another can be presence of resonant bodies, presence of resonant bodies. What is the resonant bodies? So if there will be resonant body will be there, and resonant body near the vibrating body, the loudness of the sound increases. So presence of the resonant bodies near the vibrating body, loudness increases. Loudness increases. Okay, another one, it depends upon the inversely proportional to the square of this. Here all these are directly proportional, we have seen. Another one, it is next one, it is inversely loudness, it is inversely proportional to the what we can write here, inversely proportional to the square of the distance, inversely proportional to the square of the distance from the source, from the source. What does it mean? If this source is here and one body is here, another body is here, whose distance is less, obviously intensity will be more. Let it be R, let it be R1. So obviously R1 is greater than R. This distance is more, inversely proportional. So body A will get louder sound, whereas body B will get faint sound. Clear? So what is the factors? Factors will be the square of this amplitude. Another one is to the surface area directly proportional, depend upon the density of the medium, and it depends upon the it depends upon the presence of the resonant bodies, and inversely proportional to the square of the distance. So now I will give you one question. So here question is draw two graphs. Means here displacement time graph. Okay, draw two graphs A and B, so that amplitude of A is 3 times that of B. Try to draw it. Okay, let us take this one. Draw two graphs A and B, so that amplitude of A is 3 times that of B. So here it shows amplitude of A is more, here amplitude of B it is less. Keep that one in mind. Now let us go for this diagram. So have you written this question? Now let me rub this one. I want a bigger space, that is why rubbing this. So here getting? So this one it is A, this one it is B, this is for time, this is time, and this is displacement. This is time and this is displacement. Now let us see. Here A is 3 times then that of B. Now let me draw this graph. Okay, here this much it is that length. So here it will be 3 times, 1, 2, 3 times. So if it is here this much, here also it should be. So up to this it come. So I have to, because I have to keep this pitch and quality constant. That is why I am marking this to just to know that what is the pitch, frequency level. Just here, here goes here, here. Okay, so here this one if it is A, this one it is 3A. Got it? I hope you understand this one. If question comes like this, you draw, and better to draw in the same way. If you want to draw it in the side also you can do, but as you are using the roll paper, so one or two whatever unit you will take, just multiply that one with 3 times so that your graph will be a better one. Now let us see another characteristics, that is pitch. So here pitch is the characteristics of sound by which we can distinguish a shrill sound from a grave sound, though the two sound waves have same loudness. Both these two graphs, two sound waves we are taking having the same loudness, but here one will be shrill, another one will be grave. So here one thing will be pitch of sound depends on frequency. Here if we are talking about frequency, indirectly we are talking about wavelength. Okay, here more is the frequency, less will be the wavelength. More will be the wavelength, less will be the frequency of the sound wave. Okay, so now let us see what is shrill. Shrill, more is the frequency, shriller is the sound, and here grave, less is the frequency, grave is the voice. Okay, so here this shrill sound means it is the more frequency, grave means this is the less frequency. And this pitch word we have heard in television when we hear this musical channel, or there will be some musical competition will be there. Judges, they used to advise these students or clients or participants to start it from low pitch. You are starting from high pitch. So all these things are there, no? So that is the idea for us. So here we are getting this, the shrill means that is more frequency, and grave that means it is the less frequency. So here let us see, let me draw one graph. These are very important for us. Try to understand this one. A and B, we will take these two graphs here. A and B we will take. Obviously this one will be displacement, and here this side will be time graph. Let it be A, let it be B. Okay, so here let me first of all draw this one. This one what I am trying to do, I am trying to adjust this frequency. So here let it be like this, so that whatever we are doing after that it will come properly. Okay, because in two graphs I am trying to do. Here in case of amplitude or loudness you can do that one in two graphs, but better to do this one, this pitch, in one graph only. So here let us see a graph. So here let me take, got it? This is the graph I am taking. Next one I will take, able to understand? See, now tell me, whose frequency is more? A's frequency is more or B's frequency is more? Yes, try it. Yes. Frequency of A, it is more. Frequency of B, it is less. See this one. For one time, if I am taking this is for one oscillation, that is why only I was trying to adjust. Here, for this graph A, in the particular time period, it has completed one oscillation, whereas this graph has completed half of the oscillation. Is it clear? So this one will be frequency more. So out of A and B, A is thriller and B is grave. Here I am trying to keep this loudness constant. Here loudness constant I have kept. So here loudness will be constant and pitch varies. If I will take another graph here, see, let it be C. I can keep this one here like this. So out of these three, which one is grave? Less frequency, this one C has the frequency less. A is maximum, B comes in the middle and C is minimum. Comes the interesting one. In case of loudness, we have discussed that one. In case of loudness, we have discussed it is subjective property and objective property. Here, in case of pitch, we have got two things. One will be pitch, another one it is frequency. Okay, so one is pitch, another one is frequency. So pitch and frequency, which one it is measurable? Here obviously frequency is measurable, pitch is not measurable, it is just sensation only. It is a sensation, okay, and this one it is not measurable. This one is not, it is not measurable, but it is a measurable quantity. It is a measurable quantity. So which one it is a sensation? That comes your subjective property. Frequency, it is the objective property. This is the common board question. Write the subjective property of frequency, or this is what is that objective property of objective property of objective property means frequency. Objective property of pitch means that one will be frequency, because objective is measurable, frequency is measurable. Now let us go for some of this interesting example, how we can from the sensation we can understand frequency varies. Now let us take a container. Okay, here there will be a tap, from tap water comes. First of all, this one it is the water level, this is the water level. So if this is the water level, this is the outer surface. Okay, so we can measure this one, it is the water level. So this one will be the air column. Now water level increases, water level goes there, this one will be the air column. Water level increases, this one will be the air column. Yes or no? Now let us see, in out of 1, 2, 3 cases, in which case air column is maximum? Let it be this case, air column is maximum, and we know the frequency is inversely proportional to length. More will be length, more is the length, less is the frequency. Okay, so in this case we will have less, because more it is that air column, no? So this one will be less frequency. Here this air column is less, that is why this one will be more frequency. That is why if we keep a bucket under the tap, running tap, and we are outside somewhere else, from the hearing the sound we can able to understand this bucket is filled or going to fill or filled. By how? Because when the bucket it is going to be filled, sound becomes shriller. Okay, when this what you can say, a bucket. Bucket is going to fill, then shriller becomes the sound. Shriller becomes the sound. Okay, because why this one? Frequency will be more, and here because the air column will be less. Understand? Another, usually it is said the woman voice is shriller than the man voice. Here it depends upon the vibration that is occurring on the throat. Another example can be taken in case of flute. So in case of flute, what happens? Let this one will be the flute. I have told you earlier also, I am very good at drawing, so please bear with me here. So this one will be the holes, this one holes, so all this. So when there will be blow of air will be there, this flute player, they try to close one of these holes. So when they are trying to close the holes, the air column, the length of the air column changes. So different type of sound comes from this. So by closing these holes. Another example is that when we are taking the tabla, okay, so there will be some strings will be there and we are tightening the tabla. So when we are tightening, what happens? Here we know F frequency 1 by 2L root of 4 T by M. While tightening the tabla, this frequency changes. So depending upon tension also, we are changing the frequency so that there will be a change in its frequency. So here in case of previously we have discussed tabla, here let it be sitar or any stringed instruments we have taken. The purpose of showing you this one, it is that these strings, these are the strings, and frequency also depends upon the thickness of the string. So frequency depends on thickness of the string. Thickness of the string. Okay, so here if we will take thin string, then this one will be frequency will be more. If we are taking the thickness of the string will be more, then less frequency will be produced. So depending upon frequency, we can say this one, this is thriller or this is grave. This is another interesting property of sound. The interesting characteristics of sound. Here we will discuss quality. This is the third one, quality. And quality is the characteristics of sound that enables us to distinguish between two sounds of same pitch, same loudness produced by two different sources. So this is very interesting characteristics of sound by which we can able to recognize our friends, relatives, the persons with whom we have met without seeing them by their voice. If your friend is calling you at your door and you have not seen him, still you can able to understand that one your friend is calling you. How it is possible? This is possible due to the quality of the sound that your friend is produced, and you are habituated with the quality of sound of your friend. So now this quality of sound depends on waveform. So what is the type of wave it is forming? That is the waveform for it. So here quality, it is the subjective property and it depends upon this waveform. So what it can be? Now let me write all these things. Here loudness, that is your intensity. Pitch, frequency. Quality, this one it is waveform. And here another from the light chapter I am writing. One is color, that is wavelength. All these are very important. This is subjective property. This one it is subjective property, and this one it is objective property. Okay, so remember this one also important. Board question comes like this. Now we will go for the graph, how the graph look like. Okay, so now let us see. Here I will take a graph. Which one tells us two graphs A and B? Two graphs A and B, same pitch, same loudness, same pitch. Okay, so if I am going for pitch, so obviously I will go for this one, so that it will be easy for me to draw the graph. You people also, you just see that afterwards you can rub it. So when I am going for the pitch, I am going for this way. When I go for the loudness, I go for like this. So I will go for like this. So that this one will be the amplitude. Sorry, here I have not written displacement. Here it will be time. Okay, for A, let me see. If I am going for this, here, okay. Bear with my diagram. Okay, so here I can go for it. This is rounded. I have taken this one as possible. Able to understand? So here, see the quality. This waveform changes. Here it is different. Here it is different. I can take it somewhere else like this also. Okay, so it will be like this. So here all these three cases, this quality of sound varies. Whereas all having the same loudness, they have the same pitch. Okay, but quality varies in these cases. So quality of a musical sound depends on the number of subsidiary notes and their relative amplitudes present along with the principal note. So here what we can write, different instrument, they have the different subsidiary notes. So notes of piano, here we can say piano, that is the large number of subsidiary notes, whereas flute has less number of subsidiary notes. So due to the number of subsidiary notes, we can able to recognize this sound of flute and piano. Here another interesting, it can be string instrument also, depend upon this whatever the quality. So when these string instruments are also played, by the sound we can able to recognize what is exactly that instrument is played. We will go for the concept of music and noise. Actually for me, this concept of music and noise is different for person to person. Which one is a music for me, it may not be a music for others. It may be noise for others. The simplest example let me give you. If I will talk about DJ, so DJ is a music for you people, but it is a noise for us, for me. Okay, if I will go for these old movies, old songs, then we can say it is a music for us, but you can say, oh no, this is a noise for us only. So here what we can say, this music, it is pleasant to hear. It is not pleasant. Okay, it is regular. It occurs in the regular interval of time. it is periodic. It is periodic. Okay, it is irregular. Now I will ask you one question. Honestly tell me. It is morning, let it be 6 o'clock, and you have to go to school. Every day, as usual, mother comes and tells you to get up, get up, get up, get ready for school. So that time, what you feel? The mother's voice is noise or music for you people? Huh? What is that? Yes, no? Yes. Yes, that is music or noise. I think most of you are telling that is noise only. But if that noise will not be there, no, you cannot come to school. Remember this. Okay, now it is irregular and it is periodic. This one it is, this one is regular, that is irregular. So here what we can say, sound level we can have 10 to 20, 10 to 30 decibel. This one will be here 10 dB to 30 dB. And one thing I forgot to tell you, the unit of loudness, it is decibel. Unit of loudness, it is decibel. Here unit of intensity, that one it is your phone. Here it is 10 to 30 dB, so it is decibel, and it is more than 120 dB.